Good day, guys. Welcome to part two of my little talk on real-time data collection analytics using big data tools. Big data tools here means Spark Streaming, hbase, Kafka, and little other stuffs in between. In this video, we just want to go into some details and see some of the codes, right? By the way, you can go to my GitHub account and get every code with the notes for everything that you see running here. So you can basically reproduce this in your own network or local environment. Okay, by the way, for this, I am actually using one machine that is fortunate to have enough memory and CPUs to go around. But however, I'm using a VM, but I'm going through my wireless router in the house here. So this can actually be deployed in a real distributed system. I'm using static IPs and nothing is local host driven here. Okay, so let's start by looking at the let's go back to the architectural diagram and pick somewhere to start. Let's look at the sensors. Like, okay, the sensor simulators. What they just do, they simulate sensors. It, like I say, we get the data from, they're getting this data from 1.9 gig worth of files. These files were arranged, these files are, they are just a summation of everything here, right? And they now arrange them in a chronological order. You can see that in okay, I'm a user of NetBeans, and the one that merges the file is this one, right? So I just tell it merge between this 001 and 003. It's just gonna do all that and merge the file. It's reading the file. When it does read the file, it merges them and sort them using a comparator. That comparator just picks the date, creates a date, and gets the comparator of the date. So we are guaranteed that in each file, everything is arranged in a chronological and ascending order of time. And time here means date and time portion of it. So at the end, it writes it into a file that is plt data, and that is basically what you have here. So this is an arrangement of 000 to 224, 25 to 49, 50 to 99, 100 to 149, 150 to 81, 181. So that's this file that just does that. Okay, the next one we want to look, right? So now we have the file and we are at this level. So sensor file, the sensor simulator will read these files. We read each of this file. It will just go into the directory, look for the number of files, and spawn that number of threads using a fixed thread pool. Now for each thread, it will start sending the file. So it's going to trigger a client simulator, right? The client simulator, you will see here, has a Kafka message producer, right? It will take the file, then using the Commons IO file line iterator, it will go through the file, and for each line in the file, it will send a message to Kafka. So the address it will send the message to will all come from the command line. So that is why I said the address it was sending to is let's see, it's sending to 1.192.168.8.120 and this is the topic, and that is basically what we saw in the other video. So for every line, so um five threads are sending simultaneously. Let's see if there's a wait. Is there any wait? Oh, do they do any wait? Okay, they wait a random time, right? So each thread will sleep a random time between 0 to 1 second. It will stream, and we wait a number of milliseconds, which is randomly detected, and it will continue. So that random time, we're just using it to simulate data coming in as a stream randomly, but we know it's in an increasing order of time. Okay, so that is for the simulator. Now, the next thing we will be looking at will be Kafka, yeah, Kafka is just an installation, right? So I installed Kafka, I installed Zookeeper first. I installed Kafka, and by the way, the Kafka I installed, you can get that from my YouTube channel. I installed Kafka and I did a tutorial on installation of Kafka and Zookeeper somewhere here, right? That is it. So it turns out that it is still this same Kafka that I'm talking about, right? So it is this same Kafka that I'm talking about, Zookeeper and Kafka. That is surprisingly what I'm still using to do this demo. So I fire up Zookeeper and I fire up Kafka. Then I create the two topics that I'm using. So this is the command to create the topics, just one partition and one replication factor. Then I use this command to list the number of to list my topics I have in Kafka and things like that. You can use the console producer and consumer to test that what you've done is great. So that is all for Kafka, I can say right now, right? So let's go back and see. Like I said, as long as this streaming is working, there's nothing wrong going on. Uh, this thing is just too fast. I thought I saw an error. Did I see an error? Yeah, I can see errors here right now. Oh, there's an error going on right now. Okay. But let's verify that the streaming is working. Okay, so streaming is working. I don't know why, but I can see an exception. But its streaming is going on, and if streaming is going on, we expect that data is being consumed and processed. Okay, so like I said, Kafka. This is Kafka for you. It's the streaming is working. So we're getting from now. This is a VM, but the data is coming from the host. So and in the network balance, there are two different systems because the VM is using a bridge network type on the. It's using a bridge network type, so it's totally a different machine with a fixed IP address. And even when I ping it because I set it up in my host, and when I ping it by name, I can access it. Yes, that is the same thing. So technically, it's two different machines, right? Technically, it is two different machines. Oh, that was why we had a failure, right? So yeah, that's something for me to check out. So when that is done, when Kafka gets it, the data moves into Spark streaming. So now let's take a look at the code for Spark streaming, right? So this is it. It's a Scala application. It basically uses this connector from the ITD Nedammer GitHub project. I'm a user of this project a lot. So then we instantiate Spark context. We set the configuration with details for it to access hbase, and we create the Spark streaming context with milliseconds of 250. Then we set the this is the topic and this is the broker. They're supposed to be passed in as arguments, currently hard coded. This is the downstream. This is the downstream topic. So this is the when it finished all its work. This is where how it's going to send data to the dashboard or to anybody who needs it in downstream. So we use the Kafka util to create a direct stream, right? And this is a more reliable way of integrating Kafka with Spark streaming instead of using the other receiver model, where there is no guarantee. That you have very little guarantee should data of data of not data loss of no data loss. All right. So once we do that, we get this stream that I call data. Then I start doing all the processing. So I process for each day stream and I do this method. So what actually happens here is that first in the D stream, we map the D stream to a reading object, which is just a model, right? So the model is this that has the data for all the points. All the data comes, it maps successfully, except that when I get the string date and time, I will use a Java text date simple date input format to convert it to a timestamp. And here I created a method called to tuple that will give me the tuple I want to persist to hbase. So right now I transform the object so I don't start time anymore. I don't store date and time. I just store a long that is timestamp, and I use the user ID and the time series, the reverse timestamp as the key, the row key. Okay, so when I get that, I will catch it for performance because I want to use it further. Then I start doing the trajectory manipulation. So I just get this data. I want to check where was this user before I got these data points. So I do a map partition because for performance, you should do map partitions instead of doing plain maps, right? So I do map partition, and in the map partition, I cache. That's my cache service. So this is my endpoint to Redis, and so in the cache service, I am going to work on each of these readings I get here. I'm going to the get server. So now I'm going to go to the cache server to do a get and set. Get and set means give me the last value and take the new value, right? That's it. Give me the last value and take the new value. So that's what I call get and set. Get and set for each trajectory, latitude, longitude. So if it's the first time, you expect get to be null and it will set value. So I create new trajectory. If it is null, you set it to the same thing, and you disconnect your cache when you have done for that entire partition, and you return your RDD. So I basically save the RDD, I save the trajectory to hbase. The methods to do that are these, right? And lastly, I send a message. Now this is hard coded. I'm supposed to pass it down as a broadcasted variable, right? So don't mind me. It's still hard coded. I just wrote it like 48 hours ago. Then it sends a message that says message loaded. So whoever is downstream is going to know that the message has been loaded. So you have seen that. Let's look at the cache service. This is get and set. We instantiate okay, in this case I'm using localhost and default port number for Redis, and I showed you the Redis server. So this is the Redis server, right? The key value store. Okay, I hope work is still going fine. Yes, we're good. Then we do the get and set. We get the first value, we set the one, we return the get value, and we disconnect. So this is just doing that. Then lastly, this is the Kafka message producer that sends the message to downstream Kafka. So basically that is what is happening in this one here, right here. So this is the first, this is the second, sends it here. And we're now going to look at the dashboard. The dashboard will get values from Kafka and know that new values have arrived. Then it will go pick it from HBase using Spark Phoenix. Sorry, Apache Phoenix. Right, let's see that. So I can close this. I don't have so much memory to spare. A lot of things are running. Okay, let's see that. That we will see on the. So this is the Kafka consumer. It takes a Kafka broker and a topic, and it initiates an executor of 2 threads, right? Just 2 threads. And before we get there, let's see how the main method. So the main method is the entry point is a dashboard. We have 4 panels, which is one of these, each for 1 panel, right? Then so for these 4, we instantiate 4 of them. Then each of the 4 have their handlers. So they have the handlers that updates them separately. Then we put that handlers into maps, right? So we have the panel in map, we have the map, and we have the frame, and we have the Kafka consumer. Then right here we instantiate everything that we need to do. I will show you just one as an example. and I populate the map. I create the panels and I populate their own map. I pass the map to the dashboard so that it can create it. Then the Kafka consumer, using whatever we get from parameters. We arguments, when you started with arguments, we pass in those parameters. So we set the parameters when you bring them in, and we start the dashboard. So let's see start. Start basically starts up the GUI in its own thread. So this, it runs in its own thread using the event queue.invoke later. Then on the main thread, we will start the Kafka consumer. So let's go to the Kafka consumer. We've seen Kafka before. It just starts, then it blocks on that thread. So it owns that thread. However, on that thread, it has executors. So whenever data comes, it fires up one of these executors using execute method. So this is where we had an error exception there, right? We had an exception here, right? So in one of those lambda expressions. Yes, in one of those lambdas we had a null pointer. So this is where we had that, and so we just, when we get data, we inform the system that we just got data, go reload. So each of these handlers, remember we passed, those handlers are passed in as maps right here, right? So the handlers, their dot handle hook method will be executed. So let's just see one of those handlers. Let's take trajectory by distance. So if you look in here, this is a simple SQL statement, and then this is the labels for the map for that graph, right? You see, so the handler actually extends a abstract handler because all the handlers behave similarly. So I just abstracted their behaviors. They should have a model. So this is the definition of the model, and this is how they clear and init data. So the model is built in the abstract class, kind of. So this is where we go build up the model, and we set a connection to Phoenix. So this is the JDBC URL to get to Phoenix. And so this is the schema. The schema is built from those model in the child class. And all these are just getting data and manipulating data. So the handle method will fetch new result sets. It will clear the existing data, then it will try to populate what we have new, and it will send it to the report item model. That means this class is always hooked onto by something we call a report item. A report item. We can see that in the abstract class. Report item is this, right? So meanwhile, that report item is just an interface that will be implemented by the JPanel. So this is the JPanel class that has all the, it uses JFree charts. So it will hook up to the handler. It registers itself with the handler right here. And all these are GUI stuff. It populates the graph. And this is the hook method that will be called. So this is how the handler will, this is when this handle is done, the handler will call report item dot report item model, and the user interface will populate itself, right? So everything is still happening within a week. Yeah, expecting this to change, right? So that is basically it. Everything else is just aesthetics, right? Just putting some aesthetics here, right? And this is an unimplemented feature. I wondered if I clicked on this, you see it's highlighted red, and I click view details. I want to be able to see the data streaming like you saw it in that console, right? So I don't have time to fix it. Somebody can help me, right? So that is a technical detail of how we these systems combine to give us a real data analytic um, um, kind of stuff where data is streamed in as one event at a time, but we can get it at real time and display the real an analytical view. Now this is just a pie chart. It could have been a moving average. It could have been anything else. It could have been anything else. But as long as we can get the data in real time, we can make use of it and analyze it in real time using NoSQL features. And thank God for Apache Phoenix that makes it easy. um, that has become possible. There are other alternatives. It is possible also that we could have done this with this awesome tool from Cloudera called Cloudera Kudu. Yeah, with Kudu you can do something like this as well, where you can get data and merge real streaming data with existing data together. In this case, I didn't want to go into the complexities of mixing the data, so I just notify the handlers and they refresh the data. And it turns out that the performance of I have tried it before, the performance of Phoenix is really really good in my scenario. I'm using a machine, and this VM has about 9 gig of RAM and 4 CPUs. That's what I allocated to the VM. And for that large data set, you can see I get sub-seconds response, right? So you can imagine if it's built in its own machine, if it's in its own machine and given all it should work. And mind you, on this same VM is where Zookeeper is running, Kafka is running, Redis is running, hbase is running, as well as HDFS and Yarn, right? So, but it's still behaving okay. I'm just hoping that when the data is complete, I still keep seeing a better performance. And mind you, it is plain, it's just a view, right? So there's a lot that we can really do. There are other alternatives I could have used. For example, I could have used the key value store to keep running totals so that I don't have to look up Apache Phoenix. That is still possible. But because I had short time to deliver it for the class, I had to use the simplest way possible, right? So you can keep running totals in and keep incrementing running totals in a NoSQL database like key value store Redis, such that when the data comes, your dashboard doesn't look up HBase. It's going to be faster if it looks up the key value store for the latest running total. That is another scenario that would really, really work, and I think will perform faster than what I am doing right now. So there are many ways to do it, but the cool thing is that previously this was such a rocket science, but now with open source tools in the big data space, we all are able to now get prepared for the IoT world. Now, these are use cases that can be developed for the Internet of Things and real-time data analytics. So I hope it has been useful. Like I want to refer you again. We take this kind of classes in desire.com. For instance, we another awesome one is coming either the end of this month or the beginning of next month, first weekend of next month. And we'll also be doing things on real-time data analytics using any of these tools. It could be Storm, it could be Flame, it could be Spark Streaming. But the cool thing is we do these projects real time, and all these things I walked through, most of them I was sweating through the class while writing them, right? So, but I just talk through them now because obviously it's working. Except that we have a stack trace right here. So take care, and I hope this makes sense to you. Thank you.